Okay, solving two-step equations. Well, first of all, let me tell you the basic thing about solving equations is trying to find the value for the variable, for the missing value, or for the variable. There are different ways to do it. I'm just going to show you solving equations by using the properties of equality. In other words, you've probably heard it as whatever you do to one side, you have to do to the other. And I'm doing this in order to isolate my variable or get my variable by itself on one side. Okay, so that's the procedure or the process I'm going to use to solve it. And there's other ways you can do it as well, but this is how I do it. All right, just to give you a visual, there are two sides to every equation created by the equal sign itself. So there's a left side and a right side. So on this right side I have a variable, so I'm going to go ahead and try to isolate or get this by itself again by using the properties of equality. Whatever I do to one side, I do to the other. And I'm also going to use what's called inverse operations, which are the opposites. Opposite operations undo each other. All right, so here we go. Starting, and so that's enough of that. So now I'm just going to go into all the steps. Okay, first I am going to eliminate or cancel out this addition of 2. To cancel out an addition of 2, the inverse is to subtract. So I'm going to subtract 2 from both sides, because plus 2, adding 2 minus 2 cancels out, leaving me with m over 4 on the right side, and 10 minus 2 is 8 on the left. Here I have m divided by 4, so the inverse operation of division by 4 is to multiply by 4. And the correct way of showing it is 4 over 1. And whatever I do to one side, I do to the other side as well. The inverse operations cancel each other out, thus leaving me on the right side with the m and on the left side of 32. So this value right here is the value, the missing value. I can always check it by plugging it in. Okay, so if I plugged it into the original equation right there, 32, we want to see, does this right side equal the left side? Well, 32 divided by 4 is 8. 8 plus 2 is 10. So yes, 10 equals 10. And this is how we know that m equals 32, is because we end up with a true statement. Again, I need to solve for my variable n, so I'm going to go ahead and cancel out this constant by using the inverse operation. So I see addition, I'm going to do subtraction, and whatever I do to one side, I do to the other side, thus leaving me with 0.75 n equals 11. Step 2, we want to continue to isolate n. It's being multiplied by 0.75, so the inverse of multiplying by 0.75 is to divide by 0.75. So that'll cancel that out. But whatever I do to one side, I do to the other side, 0.75. Okay, so I'm going to divide this right here, this 11, by 0.75, so that's the 0.75 on the outside, 11 on the inside. Got to move this decimal point 2 places to the right to make that 75, and however many times I move here, I have to move it the same way on the inside, so it's really going to be 75 into 1100, and so we're going to go ahead and divide that out. Okay, so n is going to equal to 14.6 repeating, or 14 and 50 over, what is that? 2 over 3, 2/3. Okay, example 3. We're going to go ahead and subtract. We see adding 6, we're going to subtract 6 from both sides. B still has this negative right here, which is like a -1. So we're going to divide by -1 to both sides. So B equals -17. Again, we have division by 12 and adding by 5. Want to isolate the K. We're going to subtract by 5 from both sides since I see addition by 5. To continue to get K by itself, since it's being divided by 12, the inverse is to multiply by 12 to both sides. Okay, so K equals a -48. We want to get this Y by itself, but we have it being multiplied by a 3, and we have this constant or this term of 8 right here. So I want to cancel the 8. It's positive, so I'm going to subtract 8 to both sides. So I'm left with a -3 being multiplied by Y equals 6. Again, I still want to continue isolating Y, so I'm going to divide both sides by a -3. So Y equals -2. So this last example looks quite different than all the other examples, but it's still a two-step equation. Why? Because we have two operations. We have addition of 3 and division by 9. This time, instead of trying to eliminate the constant of the 3, since it's grouped together with this x because of this big fraction bar, we are going to eliminate the division by 9 first. So thus we're going to multiply both sides by 9. Now we're going to subtract both sides by 3 since that's the inverse of addition of 3. So x equals 42. And that's it. Good luck.